Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on question bank discussion. That means Chopper's third module, Chopper's question bank discussions. So here we have total 20 questions. So in that, the first question is the demonstrate the principle of step up chopper and derive the expression for the average output voltage in terms of input voltage and duty cycle. So no, we know very well about step up transformer. V0 equals output voltage equals to Vs by 1 minus delta. This expression that I will derive. So now what is the circuit diagram for a step up chopper? So now here in this we have the inductor and here is a switch and here is a diode. So these are the three components to make the step up chopper or step down chopper and step up and step down chopper. And here is a Vs is the input voltage and V0 is the output voltage and capacitor is the to maintain the ripple free voltage. And now here this is the output voltage and output current. So here we need to derive the output voltage waveform in terms of input voltage. So that is Vs and V0 and this is delta. So that derivation is given in the. So now here these are the output voltage waveforms. So now here in this input voltage waveform and now here output current waveform and next here the switch waveforms and capacitor waveforms, all these are. And now here when switch is on, so what will happen when switch is on? What will happen? Switch is on means this is short circuited. So what is the output waveform? So VL equals to Vs. So now here voltage across the inductor equals to, if you apply KVL in the VL equals to Vs if you apply KVL in this loop. And next IC plus I0 equals to 0. So this is completely short circuit means IC plus I0 equals to, this current is 0, IC plus I0. If you apply KCL at this node, so IC plus I0 equals to 0, IC equals to minus I0. And same way when switch is off, when switch is off means here, so it is open circuited. It is open circuited means, so apply KVL in this loop. If you apply KVL in this loop, so VL equals to Vs minus V0. So now here this VL equals to Vs minus V0 if you apply KVL in this loop. And now here IC equals to IL minus I0 if you apply KCL at this node when switch is open. So now here we have 4. So now here volt second balance here. So this one is here. How we will determine this one is equals to, so this is actual formula. So now here volt second balance here. So VL on T on plus VL off T off. So from this equation, volt second balance equation, you can derive the output voltage in terms of input voltage. This is the output voltage. V0 equals to Vs by 1 minus D. So this is the formula. So now here VL on equals to, that is Vs, and next T on means that is dt, and next plus VL off means here Vs minus V0 into 1 dt means 1 minus D into T. So now here, so Vs is here from this we derived the V0 equals to 1 minus D in 1 by 1 minus D into Vs. So now here this is the ripple in the inductor current and ripple in the output voltage capacitor. These are the formulas, this one. And now here second question is illustrate the principle of step down chopper and derive the expression for average output voltage in terms of So now here V naught equals to delta into Vs. This is the formula. So first one here, what is the circuit diagram? The circuit configuration is different as compared to the step up chopper. So now here in this question, so this is a switch, and now here where is the switch, and here is a this one, and here is the inductor, and here is the capacitor. So that diagram I will show you. These are the output waveforms. So this I will explain. First here step down chopper. So here is a switch. So the components are same, but the configuration is different. So now here this is Vs and V naught and inductor and diode. In the previous step up chopper, so diode here is a switch and inductor is here and diode is here. So now here VL on. When switch is on means this is short circuited. It is short circuited means here supply voltage equals to Vs minus V naught. Vs minus V naught, that is VL. So V naught equals to Vs minus VL. And now here when switch is open, this is open circuited. This is open circuited. So now here what will happen? So now V naught equals to minus VL. V naught equals to minus VL. So now here that is minus VL V naught, and this is VL on. So now we know very well about volt second balance. So that is, so VL on, T on, and VL off, T off. So now here this is VL on is this one and VL off is this one, and T on means delta T, and this is 1 minus delta T. So now here from this, so the output voltage waveform equals to V naught equals to delta into Vs. And now here delta, what do you mean by delta? Delta equals to T on by total time period. And what about the RMS output voltage equals to? So that equals to square root of delta into Vs. So now here next question, third question, explain the 4-quadrant chopper operation with neat switch. So this is the 4-quadrant chopper. It is also known as a type E chopper. So it operates in all 4 quadrants. So voltage current plane here. So it operates all 4 quadrants. So it can provide both voltage and current, both positive and negative, and voltage current and both positive and negative. So here this chopper can be controlled in forward motoring mode, reverse motoring mode, and regenerative braking mode in both forward and reverse direction. So this is the circuit diagram. So D1, switch 1, S1, S4 and S3 and S2, and D1, D2, D3, D4. So now here this chopper, 4-quadrant chopper is used in the sophisticated motor control systems where complete control over monitoring and braking in both direction, that means forward and reverse direction, is needed, such as in the electric vehicle drive systems. So this 4-quadrant chopper drive we will use. So here this 4-quadrant chopper, this chopper class E chopper, voltage current both are positive and negative. So demonstrate step up and step down choppers with neat diagram. Step up, step down means this is a switch and this is the diode and this is the inductor, capacitor, and this is the load and this is the supply voltage Vs and V0, switch S1 and diode D, L and capacitor C. This is step down chopper. And we already discussed about switch step up chopper. Step up chopper means this is the inductor and this is the switch. This is switch, and next here this is the diode, and next this is the capacitor, and here is the output voltage V0 and Vs and L, and this is switch S1 and D and C. So step up chopper. Demonstrate the control techniques used in the chopper. So these are the control techniques here. Chopper A, class A or type A, and chopper B, type B, and chopper C, type C, and type D, and type E. So this is a 4-quadrant chopper. Okay, now first quadrant chopper, 2-quadrant chopper. So these are different types of choppers. And next, compare the control techniques, class A, class B, class C, class D, class E, or type A, type B, type E, type C, and type D. So now here only the difference is voltage and current, positive or negative. So for class A, the voltage is positive and current is positive, and it is operated in the first quadrant, and it is used in the forwarding or motor forwarding, DC motor speed control, that is in the forward control only. And next in the type B chopper, and it is operated with positive and voltage, positive voltage and negative current. It is operated in the second quadrant, negative current and positive voltage. The regenerative braking, so in the motor control only. And next here, chopper C is a positive, voltage is positive, but here current may be either positive or negative. So 2-quadrant chopper, first and second. Now here it is operated in with forward motoring and regenerative braking. So in the both it will works. And next, chopper D is either voltage is positive or negative and current is positive, but it works in the first and fourth quadrant, forward and reverse motoring, not forward motoring. Forward motoring and reverse motoring mode. And next, the last one is either voltage is positive or negative and current is positive or negative, and here it is all 4 quadrants it will operate. It is full control in motor drive systems, includes reverse motoring and reverse brake. And next, AC chopper. So that means chopper, DC chopper means either you need to variable DC and variable AC. So this is variable DC, means you can increase the voltage or decrease the voltage by using the delta, duty cycle, buck converter, boost converter, buck step up chopper, step down chopper. But here AC voltage, input voltage, that means AC voltage controller, so that are employed to vary the RMS values of alternating voltage applied to the load circuit by introducing the thyristors between the load and source. So that source must be AC source. So RMS value of alternating output voltage applied to the load circuit is controlled by controlling the triggering value of thyristors. So this is, so here we have different types of controlling techniques, on off control technique and phase control. This we already discussed. And next here, develop the expression for minimum and maximum output currents of class A. So this one is also we discussed in the previous lecture in the class A chopper. And now here in the class A chopper, it works on the first quadrant operation. Our voltage is positive and current is also positive. Both are positive. And now here current is flows from source to load, and now here this is output voltage. This is the circuit diagram for first quadrant chopper, that means class A chopper. And ninth question is explain the uh, waveforms constant, variable and variable frequency and chopper, constant frequency chopper. So that how it will works. So now here variable frequency and constant frequency means here. So what is the delta equals to T on by T. So now here delta equals to T on by T on plus T off. So constant frequency means here. So here it is constant. So this also we already discussed this waveforms. So here T on is variable, T is on. It is variable. T on is, this is time period. So it is a variable, but T is a constant. So sometimes here this T is variable means here this is T is constant means T is variable means here it is variable, T on is constant. So that we already discussed. T means here T changing means time frequency is also changing. Examine the effects of the source and source inductance and load inductance on the chopper. So now here there is a effect of source inductance and inductance on the converter performance, because the presence of alters that output voltage, and as the results output voltage reduces, load current reduces. In addition to that, so the input current and output voltage waveforms may change significantly. And explain the operation of Cuck converter. And now here this is a circuit diagram for Cuck converter, and this is the output voltage and Vs, input voltage and output voltage V0. And in this we will use two inductors. One is the L1 and L2, and two capacitors C1 and C2, and one switch we will use, and one diode that is in downwards direction. And these are the output waveforms. So now here in this waveform, so here IC1 and VC2 and I0 and IC1. Demonstrate the buck boost voltage regulator and with a neat diagram. So buck boost voltage means here this is the switch and this is inductor, and I think this diagram is wrong. Already we discussed buck boost converter diagram. And now here class C chopper. Explain the operation of class C chopper with neat diagrams and waveforms. So first thing here, so class C chopper means two quadrant chopper that is operated in first quadrant and second quadrant. So here voltage is positive and current may be either positive or negative. So first and second quadrants it will operate. And type A combines with, this is type A and this is type B chopper. So current flows from source to load as well as load to the source. So this bidirectional current. And now here the first quadrant chopper, so load receives the power from the source to the source, and in the second quadrant chopper, so the load sends the power back to the source, that is regenerative braking. So this chopper can be used in the forward motoring and regenerative braking. So what are the applications here? So DC motor control, where the both forward motoring and regenerative braking are required. Explain the operation of class B or type B chopper for resistive load with circuit diagram and output voltage and output waveforms. So now here this is the voltage current diagram. So it is operated in the second quadrant, that means output voltage is positive and next current is negative. It allows the regenerative braking action for motors, and when the chopper switch is off and current flows back to the load to the source, and this is the circuit diagram. This diode will allows the from the load to the source. Here is a switch. When switch is off, the current flows back to the supply due to the energy stored in the inductor, allowing the load to regenerate back to the supply. So it is used in the regenerative braking of the DC motor. Next, demonstrate the operation of buck converter. So this diagram also, this one is also we discussed. So buck converter diagram means here this is a switch. This is one diode, this is one inductor, and this is one capacitor. Load, that is V0, Vs, switch, diode, L and C. So here V0 equals to delta into Vs. This already we discussed. Now here illustrate the operation of buck boost converter. So this one is also we discussed. And next, interpret the operation of class D chopper with the help of circuit diagrams. So first one is class D chopper means two quadrant chopper, the type B. So in this the voltage is either positive or negative and current is always positive. And now here in this case, so in the first and fourth quadrant it will operate, current is in positive direction, and now here voltage is either positive or negative. So switch S1 and S2, diode 1 and diode 2 are connected in this fashion. So now here in the first quadrant the chopper provides voltage and current forward monitoring, and in the fourth quadrant it will provide current become negative. It will allows the reverse motoring. It is used in the situations where the forward and reverse motoring operations are required. And next question, 18th question. So class C chopper already we discussed. So in the four quadrants chopper, 1, 2nd, 3rd and 4 quadrants it will operate. Voltage either positive or negative, and current is also either positive or negative. Both it will works, and it can control forward motoring and reverse motoring, regenerative braking in both forward and reverse direction. And they are used in the sophisticated motor control where complete control over motoring and braking in both the direction is needed, such as electric vehicles drive systems. We will use this 4 quadrant chopper, that means class E chopper. And next, 19th question, buck converter design specifications with need diagram. So that we have already discussed. So this is a diode, switch, and inductor, capacitor, and load and supply voltage Vs and V0. V0 equals to delta into Vs. So this one is also we discussed. And next, boost converter means this is the inductor and this one is the switch. Switches and a switch and inductor, that is L. And now here this is the diode and this is the capacitor, and now here this is the load. This may be a load, and now here supply voltage plus minus Vs and V0 equals to Vs by 1 minus delta. Delta means T on by T, and T on by T on plus T off. So this is the diagram for design considerations. Now I hope all these 20 questions are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.